All right, hi everyone. Okay, just kind of give you a rundown of some of the things we did in class on Wednesday, the what day is it? 29th, October 29th. So we started trigonometry. This is not your first rodeo with that. So just wanted to go through some basics. And one of the things, I'm just going to draw a circle. Here's the center of the circle. Here's the radius of the circle. And I'm going to section out an arc length here. And I want this arc length to be the same. This is S, is usually the variable for arc length. I want this to be the same measure as the length of the radius. And if I have done that, then this angle theta here is equal to 1 radian. All right, now if we go through and just kind of partition that number of radians, or that arc length here, I'll go a little bit further with that. I'm actually going to draw a y-axis in here and an x-axis. And if I go a little bit, take another arc length of length r here, and then another one of length r here, trying to make these about the same, kinda. And so this is my second arc length, this is my first, there's my third, and I just keep going around. Here's my fourth right here. I take my fifth one to right around here, about the same, and the sixth one to right around here. And something we noticed was this was the 180 degrees, we know is half a circle. It's a little more than 3 radians, and it's actually 3.14, etc. Pi radians is equal to 180 degrees. 2 pi radians is equal to 360 degrees. So that was the first thing we just kind of discovered. And then we worked with some angles. I'll draw another circle here. And let's say that I have, let's see, let's say I come out here and I say that this, measuring an angle from this terminal side, or initial side, this is the terminal side. Let's say this is 2 pi over 3, 2 pi over 3 radians from here to here. Now we talked about coterminal angles. Coterminal angles would have the same initial and terminal side, but our angle could do like a revolution. We could go around and come back here. So if that's the case, this 2 pi over 3, we have added, we hit the 2 pi over 3, and then we went another whole lap around, which is 2 pi. And if I write that as 2 pi over 3 plus 6 pi over 3, that's 8 pi over 3. Okay, this is a positive coterminal angle. Or I could, and positive direction is counterclockwise. Clockwise is the negative direction. So I could start here and go this direction. See, I got the arrow going that way. And that could be found by taking 2 pi over 3 minus 2 pi, or minus 6 pi over 3. And that's negative 4 pi over 3. And this is a negative coterminal angle. That's one of the things we did. Now, the other thing we did was converting, let's go degrees to radians. So if I'm converting degrees to radians, this ratio, pi radians, is equal to 180 degrees. So that is this would be what we would multiply our degrees by in order to convert it to radians. Because pi radians is equivalent to 180 degrees, if the numerator and denominator are equivalent, we're just multiplying this by 1, and it'll help us change the units. So I'll just write this, and then we'll do a problem with it. Multiply degrees by this. Okay? So if I have, let's say I have 210 degrees. If I multiply that by pi over 180 degrees, the degrees are going to cancel out. I'm going to divide by 10, so I can just cross off those zeros. If I divide by 3, that's 7, and that's 6. So this is 7 pi over 6 radians. And a lot of times, if it's as a multiple of pi, if it's written as a multiple of pi, it is considered to be radians, or understood to be radians. And then we did some practice problems on that, and then we converting radians to degrees. Okay, we will multiply by, we're going to just flip that, 180 degrees over pi. And so if I want to convert, let's say, four pi over 5. That's not a unit circle, but that's all right. I'm going to multiply this by 180 degrees over pi. I'm converting 4 pi over 5 to radians. Sorry, it's in radians. I'm converting it to degrees. So I'm going to cancel out the pi's. 180 degrees, if I divide 180 by 5, 5 divided by 5 is 1. 180 divided by 5 is 36. 4 times 36, and notice it's just 1 on the bottom, so I'm just going to write that as 144 degrees. Okay, that just pretty much encapsulates what we did in class, and we just dealt with problems from the book that dealt with those kind of questions. If you're going to get some practice, you would be on page 261 for the coterminal stuff. That is 25 through 28. For the degrees to radians, that's page 262, 47 through 50. And for the radians to degrees, That's page 262, 51 through 54. And that's pretty much how we spent class, just doing those problems. All right, take care, guys.